All right, so for 3.2 here today, it's kind of a continuation of our notes where we last left off yesterday. And what we're just focusing on with these linear equations here is the concept of slope and what slope actually means. So in the notes, I'm just kind of starting here, 3.2 notes is probably the best way of putting it, is first of all, what is slope? What does slope actually mean? So first of all, in a math sense, in order to figure out slope, you would need to be given two data points. We like to call the first data point x1, y1, since x comes first, then y, and then x2, y2. It genuinely doesn't matter which point you define as x1, y1, and which point you define as x2, y2. So slope means rise over run. How much are you going up or down versus how much you're running to the right? So how we calculate it out mathematically, since rise is up, down, those are the y values, we like to go y2 minus y1. Divided by the run, which would be x2 minus x1. Now, could you flip these around? Absolutely. But if you flip the y's, you must flip the x. Now, once you get the slope, since it means rise over run, one way we like to interpret it, say in a real world sense, is the slope really tells us how much something increases in the direction of y for every one x value. So how I like to do it is I like to give students kind of this fill in the blank sentence. For each one x value, so whatever it says in context, I put right here. The y value in context, either it increases or decreases. So if the slope is positive, I say increase. If the slope is negative, I say decrease by the whatever the value of the slope. So in today's lesson, what I want us to be able to do is first find slope and then tell us what it means in the context. So I'm going to run you through an example, and then in the assignment here today, you just have, I think, 3 problems where you have to do something very similar to this. Okay? So actually we have 2 example problems here. My apologies. So the first one here is just practice on finding the slope. So slope again is the variable b. I didn't mention that earlier, but you can see right up there it's b. So again, it's y2 minus y1 over x2 minus x1. So notice how I'm given 2 points. So I'm going to label the first point x1, y1, the second point x2, y2. So now I'm simply just going to start plugging these numbers in and simplifying. So y2 is negative 7. y1 is 2. So negative 7 minus 2 over x2, negative 2 minus x1, negative 8. So this is where you got to really watch your signs. Okay, so if I go negative 7 minus 2, I get negative 9 in the top. In the bottom, I have negative 2. I'm subtracting a negative 8. So watching your signs is extra careful. Over 6. So now if I divide those, negative 9 divided by 6, I get a slope of negative 1.5. So for every one x value, the y value decreases by 1.5 units. So it all depends on what things are, what it represents. So I might say for each 1 year, the value of the car decreases by $1.50. That'd be really nice. But I'm just trying to make up a context off the top of my head. So now, giving you a problem in the top context, let's take a look quickly here at number 2. So number 2 says the number of schools, and I've kind of changed this up so it makes a little more sense. The number of schools in the U.S. in 1960 was 35,182. And the number of schools in 2000 was 46,812. A says let X represent the year and Y represent the number of schools. Find the slope of the line connecting these 2 points. Wow, so let's first of all define the 2 points. So in 1960, since X represents the year, I can say 1960 is my X. The number of schools was 35,182. Sorry, I just want to put a little comma there. Now, in the year 2000, boy, we could probably, whoops, I started writing 2020 because I started thinking of this year. 2000, we had 46,812 schools. So I'm grabbing the points from the information they give us. So now I want to find slope. So here's x1, y1, here's x2, y2. So in the top I have 46,812 minus 35,182. We'll divide that by 2,000 minus 1960. So if I think about this, I'm looking at how many more schools did we have? So 46,812 subtract 35,182. So there was an increase of 11,630 schools over 2,000 minus 160. I think many of you could probably do that in your head, and you would get 40 over 40 years. But now if I take that answer, that 11,630, and divide it by 40, this basically tells me how many more schools, okay, there are per year. So when I get to B here, it says, all right, let's interpret the real world meaning of the slope. So I'm kind of going back to this sentence. So I'm going to start by saying for each additional one year, and because the X value represents years, so for each additional 1 year, what does the Y value represent? The number of schools. The number of schools in the U.S., so we're talking about the United States. Since the slope was positive, I say increases by, now my slope value, 290.75 schools. Now I know some of you might be saying, Mr. Bartz, you can't have 0.75 of a school. Well, I agree with you, you can't have 3/4 of a school, but we still report it as a decimal because this is like what happens after 1 year. My guess is you can't build all schools in 1 year. Sometimes they take more than a year. All right, this example especially is going to help you with your assignment today. I believe your assignment has 3 problems just like this where you're going to find the slope and then interpret the slope in the context of the problem. All right, have a great day, and we'll see you tomorrow.